150 million rodents are killed every year in biomedical research in the United States alone. That's the number that I discovered when I tried to figure out how can I help the mankind. Developing new drugs seemed like a straightforward way to achieve that, although in order to do that, I had to solve this animal welfare problem. A lot of animals were killed, and still we didn't, or it seemed that we didn't solve many diseases. So I went on a research, and it seemed that discovering a new drug is a lot like sending a man to the moon. Billions of dollars, takes decades, and even if we do that, it's still not enough. Chances of success are pretty low, and we seem to fail at every step to cure debilitating diseases. So I went deeper. I wanted to figure out how are drugs made. And holistically, you only need to do 3 things. Number 1, you have to figure out a molecule that's going to solve a particular disease you're trying to tackle. It is going to be a hypothesis on what's going to work for that particular disease. Once you have that, you need to go to step number 2 and see whether this drug is going to be helpful in animals. If that's true, and you can actually tackle the disease in animals, we go to step number 3, which is testing it in humans. If you can pass the human trials, now all of a sudden you can bring the drug to the market and you can solve the disease in question. However, it seemed to me when I was doing this research that testing on animals is necessary. And I had a big problem with that 150 million rodent number, and I wanted to figure out why. Why are the animals necessary in drug discovery? Well, it boils down to a simple fact that when you want to administer a drug, and you want to do that for therapeutically relevant doses, there is a high likelihood that this drug is going to be toxic. And we really want to mitigate toxicity side effects in humans. We don't want to be killing humans before we have any sorts of proof. So the best bet that we have in doing so is taking similar organisms, complex biological organisms that have many tissues like our own, and hoping that we can discover these toxicity side effects early on. So if we can accept the fact that we need to mitigate these side effect risks in animals before going to humans, and the animal testing is necessary and central for the drug discovery, then can we do anything better? Well, in order to improve the animal research, let's maybe have a look at what animal research is really about. Looking at these 2 pictures, what would you guess the time span between them is? It's a couple of days, weeks, maybe months. Try 60 years. The same manual procedures that we did 60 years ago, we are doing today. Manual labor that's not automated, that's stressful and harmful to animals, and produces 0 results. Animal research is very archaic. There's no real innovation, there's no advancements, and that's only contributing to the dire statistics in the drug discovery process. We need to do better. Then, if this is a central fact and we can't do without animal research, how can we then improve the process itself? Well, imagine you are a scientist and you want to develop a new drug for a muscle disorder. Now, you spent years coming up with this new molecule, and you have a great hypothesis what this molecule is supposed to do, and now you want to go and test that. The gold standard assay to do that is to take a grid, put the rodent on top of the grid, and then wait until the rodent falls off. Which, by the way, if they are young, this can be hours on end. You need to repeat that over a couple of days, average the results, and that's your gold standard. That's your best-in-class data to tell you whether your drug works. If this is the best we got, is it even surprising that we aren't really solving the diseases? Is it even surprising that we are spending billions and decades to even attempt to tackle them? We need to fix this. We need to come up with ways to do this better. And really, there's two things that we can do. Only two levers to pull to attempt solving animal research. Number one, automation. We need to employ AI and robotics to tackle all of the bad side effects with animal research. Poor data, poor animal welfare, slow time to insight, and not reproducible experiments. Second piece of the puzzle is hominization. We need to take existing animals and try to engineer their biology to be more human-like. If we can do that, we can take these animals that are genetically engineered and test on them with much higher translational power, meaning we can use fewer human-like animals to get better data insights. And that's exactly what we did at Olden. We said, let's take this automation and hominization need, and let's build out a technology pipeline to tackle exactly that. The idea behind it was, if we can enable scientists to take a drug, develop their hypotheses, and let the robotics and AI paired with genetic engineering execute these tests and answer a very simple question. Will this drug work in humans with the least amount of animals in the experiments? Let's take a closer look at what this automation pipeline looks like. Here you see the first product that we developed, which was an AI smart cage. In essence, it was a hardware that employed computer vision algorithms to track animals in the cage. If you can effectively track them, what you can do is you can estimate 20+ health biomarkers. These health biomarkers are then used to generate not only higher quality data, but then also quicker time to insight. In order to demonstrate that this technology works, I want to show you a very simple experiment. 8 health biomarkers that you see here were evaluated for 3 groups: young, healthy animals, middle-aged, and old, frail, and sickly animals. The idea is, if we can actually catch these patterns in the health biomarkers, we can see a perfect downward trend between these 2 groups. And that's exactly what you see in the graphs depicted here. Second piece of the automation puzzle, robotics. By now, we have helped our muscle disorder scientists gather the data necessary to determine whether the drug works for that disease. But then there's still a lot of tasks that need to be done outside of the cage. Think animal husbandry, food and water intake, cleaning the cage, drug administration. A lot of manual labor is still needed and necessary even after doing the experiments. In order to facilitate that, we developed world's first fully autonomous robotic system to handle the animals, to provide for them in an unbiased, fully automated way, allowing for better care and welfare of the animals. Third and final piece of the puzzle, hominization. What you see in this picture is a fluorescent image of a rodent after we genetically engineered its DNA across all body. The reason why we wanted to do that is we wanted to change the DNA to depict certain human-like features. If we do that, what we then can do is take this animal that's already more human-like and then test only on these samples and get better data insights versus just doing it across hundreds and millions of rodents done today. So what is the future for our muscle disorder scientist? Is this scientist still going to have manual labor involved in his experiments? Are we still going to have a grid that's standing in front of the scientist for hours and him or her waiting for the animal to fall off? Is this going to be the best data gathering that we can do, or is the future a little bit better? What we foresee is a future where you can rent out an ethical animal experiment from the cloud, the same way you can rent out a physical computer, whereas now, as a scientist, you can focus on developing your molecule and let the AI, robotics, and genetic engineering execute and generate the data, and you getting the answer, will this drug work in humans? But even more important than that, what is the future for humankind, for all of these debilitating diseases that we are experiencing? We saw what's the reality in the last and the current century looking at animal research. Manual labor that's sacrificing and killing hundreds of millions of animals per year. We are doing all of that just to fail in curing the diseases. Is Alzheimer's, Parkinson's, stroke, and cancer still going to be leading causes of death? Are we still going to be killing hundreds of rodents in vain, or can we do better? Thank you.